Today we want to start being very systematic in how we go about solving triangles. That means classifying the triangles that we want to solve and identifying the tools that we have for solving triangles in either of these situations. So the way we're going to break this down, and the way we've already started to solve these problems, is to look at these two big categories. Do we have a right angle in our triangle or do we not? So we have a completely different tool set for solving right triangles, a much more simplified tool set for solving right triangles than we do for solving oblique triangles. Oblique just means there's not a right angle. Alpha, beta, and gamma are not right angles. This is the setup that we're going to use in general for solving triangles. I'm going to set up the three sides as A, B, and C. I'm going to set up the angles opposite those sides as alpha, beta, and gamma. That is, alpha is the angle opposite side A, beta is the angle opposite side B, and gamma will be the angle opposite side C. Since we like C to be the hypotenuse so much in right triangles, our right triangles, the gamma is going to be the right angle. All right. Questions? So we are always going to set it up with alpha opposite A, beta opposite B, and C will be the hypotenuse since we have a right angle in the right triangle part. In an oblique triangle, gamma is not going to be a right angle, so C, we can't call C the hypotenuse. There's no hypotenuse in this oblique triangle because there's no right angle. So this is a right angle. So this will be our standard setup. I will always include this picture like I did on the first quiz that's been posted. This is just a convenient thing for us to do. Alpha is opposite A, beta is opposite B, C is the hypotenuse or opposite the angle gamma. Any questions? Let's start listing the tools that we have already. So the first tool that we have that applies to both categories, the tool that sits in both sets, is that the sum of the angles of a triangle is 180 degrees. So the angles of a triangle are supplementary. So the sum of the angles is 180 degrees. And that works in both. That's always the case. So in the case of right triangles, if we want to put the names in there, we could say alpha plus beta plus the 90-degree angle is 180 degrees. In a generic oblique triangle, we would just say alpha plus beta plus gamma is 180 degrees. So that's the first tool that we have in solving triangles. The sum of the angles is 180 degrees. This brings us to an interesting, or a good place to start. I don't know if interesting is the right word. I use interesting probably a lot too much, but this gives us a good place to start. If we know two of the angles in the triangle that we're trying to solve, if we have two angles in hand, we can just subtract to get the third one, and that's the easiest thing to do. So that would be a good strategy that we want to point out. If you have two angles, subtract to get the third angle because it's easy. The way that the solving triangles game is played is you get three pieces of information and you have to go and find the other three. So we're just going to talk about the tools that we have to solve. I forgot to talk about what the actual game was, because I was typing it up yesterday and I thought, then I remembered today, I didn't say that yesterday, so I got to say it today. The game in solving triangles is given three pieces of information, find the other three. So the game is given 3, find 3. Given 3, find 3. If two of the pieces of information that you have are angles, you can just subtract to get the third angle, and now you have an abundance of information. That's one of the 3 things that you have to find. So that's the great thing about that first tool. It applies to both categories, and it's very simple to implement. So the sum of the angles is a relationship between all the angles in a triangle. We have a tool that only belongs in right triangles, which involves just the sides. What was the tool that involves just the sides in a right triangle? What was that tool called? The Pythagorean Theorem. So that's a good thing to have. So in a right triangle, we get to use the Pythagorean Theorem. And that says the sum of the squares of the legs of a right triangle, I spelled B wrong, is equal to the square of the hypotenuse. The sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. We don't get to use the Pythagorean theorem in an oblique triangle because we don't have a hypotenuse. So in oblique triangles, no hypotenuse. So no Pythagorean theorem. No hypotenuse, so no Pythagorean theorem. Don't worry, there will be plenty of other relationships between the angles and the sides in our oblique triangles. So we've got one thing that applies to all, that relates all the angles in a triangle. And in a right triangle, we have an equation that relates all the sides of our right triangle. What we need is some connection between the sides and the angles. And in a right triangle, we can use our trig functions. So we looked at our trig functions, and they're sitting firmly in the category of for right triangles. So a connection between sides and angles is the trig functions. Specifically as ratios. So these are the 3 things that we have to remember from yesterday. So I'm going to use the generic name for an angle, theta. So what are the trig functions? What is the sine of theta? What was sine of theta in terms of the sides of a right triangle? After this, I'm going to ask for cosine theta as a ratio, and also tangent of theta as a ratio. Sine is opposite over hypotenuse, so we abbreviate that opposite over hypotenuse. What is cosine of theta? Adjacent over hypotenuse. And tangent of theta? Opposite over adjacent. Great. So the trig, so I didn't call out specifically an alpha or a beta in this one. We didn't call out specifically an alpha or a beta in this one because we are using the terms opposite and adjacent. So side A is opposite angle alpha, but adjacent to angle beta. So it depends on what angle we're looking at in setting up this relationship. So that's why I switched to theta, even though theta does not appear. So the theta could be an alpha or a beta, and then the opposite and adjacent will be A or B, depending. So trig functions are a way to get at to get a relationship between sides and angles. An important thing to recognize is that we can use trig functions to find a side, or we can use trig functions to find an angle. So the trig functions, since they're a relationship between the sides and the angles, we can use the trig functions to find angles or to find sides. The trig functions can be used to find sides or angles. What we saw in the, let's see, tons of examples we did. One example that we did yesterday, we can use the trig functions to find angles, but since the angle is inside the trig function, the tangent trig function of the angle, we had to do an inverse function to find an angle. So if we're using these ratios to find angles, we're going to use inverse trig functions to find angles. These are the tools that we have in the solving right triangles toolbox. The sum of the angles is 180 degrees. The Pythagorean Theorem says the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. And the trig functions, which relate the sides to the angles. Any questions? Now it's just a matter of practicing solving these triangles and coming up with efficient strategies to do so. We always want to come up with nice, efficient strategies. Any questions before we start talking about strategy? Great. Let's break it into the different kinds of given information. Because the given information will be part of what strategy we use to solve the triangle. So once again, I have to give you 3 pieces of information, and then you have to go find the other 3. So remember, our game is given 3, find 3. Given 3, find 3. And I want to focus on the different ways that I can hand you information and give you a triangle to solve. So this is, what kind of information can I hand you in a problem? So that's what we want to talk about today. What kind of information can I give you? And in the category of right triangles, there are 2 things that I might do. So right triangles. One of the pieces of given information here is that one of the angles is a right angle. So if I say, here's a right triangle, I've given you 1 piece of information already. So first bit of information, one of the angles is a right angle. And that's 1. Now, there are two problems that I could ask after this. I could either give you an angle and a side or two sides. So that's how we're going to break this into cases. I can give you an angle I can give you another angle and a side, or I can give you two sides. The sides may or may not be the hypotenuse. So this may or may not include the hypotenuse. It could just be the opposite and the adjacent, or it could be the opposite and the hypotenuse, or the adjacent and the hypotenuse, or I think I got them all. So the side that you're given may or may not be the hypotenuse. It doesn't have to be. But in the case of a right triangle, the strategies that we're going to use, we don't have to separate that into a separate case. So I'm just going to make a note, though, that the sides may or may not be the hypotenuse. It's not going to change our strategy. So if we look at what we're given here, if I say you're given a right triangle, I've given you one of the angles already. Then I have to give you two more pieces of information because that's the game. I give you three. So one, a right angle. Two, another angle and one of the sides, or the right angle and two sides. Any questions? Great. The easiest of these two is if you're given another angle. Let's take each of these cases. Oh, the other big category that we're going to look at is oblique triangles, where you're just not given a right angle. Then I have to give you either three sides, two sides and an angle, or two angles and a side. So I just have to categorize the information a little bit differently. So big category two. For those of you who do not like having outlines with only one entry in them, is going to be our oblique triangles. And the cases will be three sides, two sides and one angle, two sides and then one angle in a different way, and then two angles and a side. I said it, I will write it. These are all the different ways that I can give you three pieces of information about a triangle and ask you to find the other three. I can give you three sides. I can give you two sides and an included angle. I can give you two sides and a non-included angle. We'll talk about what that means later. Or I can give you one side and two angles. There is a set of three pieces of information about a triangle that I did not list. What's missing from this list? Let's take a minute and think about, there's something missing here. So angle, angle, side, 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 angle, side, side, angle, side, angle, angle. What's missing? Three angles. So what's missing from the list? It's going to sound weird in the recording because the recording doesn't include the chat. And so someone, while I'm sitting there blah, blah, blahing, someone types the answer, and it looks like I'm just answering my own questions. Sometimes I'm just going to do that because I just won't want to wait. But while I was like all listing all these things off, you're like, oh, three angles is missing. And so it sounds like I'm just answering my own questions. So what's missing from the list? 3 angles. So good catch there. Notice that I did not say, let's solve a triangle given 3 angles. How come I can't give you 3 angles and say solve the triangle? Why doesn't this work? Not that it's not necessary. It's a different thing than not necessary. It's not that it's not necessary. It's stronger than that. So the question is, why not include? It's stronger than not necessary. Right, so we don't have the 3 pieces of information. I give you 3 angles. Why couldn't I say solve the triangle? It's not that we already know all the angles. What about the sides? I just gave you the 3 angles. I didn't tell you anything about the sides. What can we use to what can we use to solve for the sides? Inverse trig functions are used to solve for angles. So this is going to be our open question for the day. How come in all these different, I have to give you 3 pieces of information and I'm asking you to find the other 3. Why am I not including the problem where I give you 3 angles and ask you to find the 3 sides? Why not include this? Why will I not ask you to find 3 sides? That's our open question for the day. Why will I not ask you to find all 3 sides? So that's our question for the day. Why am I not going to ask you to find all 3 sides? Because I'm not. So don't think of it from a student perspective. It's like, oh, we don't need to know that because you told us that you're not going to ask that question. That's not what I mean. Why am I not asking the question? All right. So let's talk about strategies in solving right triangles. And I broke it down into these 2 cases. I give you another angle and one of the sides. So you got angle, angle, and a side. Or I give you 2 sides and the right angle. Strategies. So thinking about strategies in terms of solving triangles, let's go back to our toolbox. Let's take a look at our toolbox again. In our toolbox, we got the sum of the angles is 180, we got the Pythagorean theorem, and we got these new fancy trig functions. Of these 3, which one does it look like is going to be the easiest to use? They're all pretty straightforward to use. But trig functions involve our new functions. The Pythagorean theorem involves squares, and that means square roots. The easiest one to use looks like it's going to be the sum of the angles. It only involves addition. Sum of the angles is 180 is the easiest, and it also applies to any triangle that we're looking at. So that's going to be the easiest one to use. So in the category of strategies, what I want to observe is that the easiest tool to use is the sum of the angles is 180. In the category of easiest tool to use. What that means is that as soon as we have 2 angles, we should subtract to find the 3rd one. As soon as we're looking at a situation where we have two of the angles, let's just subtract, find the third one. That's the easiest thing to grab. So that's going to be one of our strategies. As soon as we have two angles, I spelled as wrong. We should subtract to find the third. So this is going to be one of our strategies. As soon as we have two angles, we should subtract to find the third. The reason that we want this as a strategy is because it's the easiest way to get a new piece of information. As soon as we have two angles, we should subtract to find the third. And then we'll have an abundance of information, and we're 1/3 of the way to solving the triangle. That's the easiest one to use. So let's look at an example of what that looks like. The reason that I'm pointing this out is that this tool shows up right away in the first case of solving a right triangle. So for example, let's suppose that I told you that alpha was equal to, I need an angle 37 degrees. Side B is equal to 15.1, and angle gamma is equal to 90 degrees. That is, we're looking at a right triangle. I'll draw a picture of it so that we're all on the same page. So we're given gamma is 90, alpha is 37 degrees, and side, so this is side A, if that's alpha, then beta will be the other acute angle, and side B will be opposite that. Our gamma is our right angle, and so C is going to be our hypotenuse. So here's our given information. The first thing that should the thing that should jump out at us, is that we have a right triangle, and we're given given one of the acute angles. So we should immediately just subtract to find the third angle. We want to do things with as little thinking as possible when we can. We want to build in some reactions. We want to think about some things. We want to understand things. But the reason that we do math classes is so that we can stop doing all this math all the time. The reason that you learned your algorithm for subtracting numbers is so that you don't have to do that all the time. So I see two angles. I immediately want to subtract to find the third angle. So here, we're given two angles. So we subtract to find the third. I'm going to put exclamation points to say, there's two angles. We should immediately do this. So we'll take the 180 minus 90. So beta, the angle that's missing, is 180 minus 90 minus 37. So that's the 90 minus 37. If you're thinking, why don't we just start by subtracting the alpha from 90? That would be a good way to shorten things. So 90 minus 37 is going to be 60 negative 3, otherwise known as 53. Oh, sorry, 50 negative 7, also known as 53. Is that right? And we've already got one of the three things that we're looking for. We have two angles, so we should subtract to find the third angle. That should just be a reaction. We should just do that right away. Now we have an abundance of information. How do you spell abundance? Dance. Abundance. Spelling is also not my strong suit. Spelling and arithmetic, very difficult for me. So now we have an abundance of information. Any questions? That's what we want as our first strategy. If we have two angles, subtract to find the third angle. As soon as you have two angles, subtract to find the third angle. Let's look at another example. So given a right triangle and one of the angles in the right triangle, we should subtract to find the third angle because that's going to be a situation where we have two angles. And as soon as we have two angles, we should subtract to find the third. The other right triangle's case is that if we're given two sides. Here, we're going to have to use inverse trig functions to find an angle. So let's suppose that A is 5. B is 12, and we have a right triangle. So what we notice is that we don't have two angles, so we're not going to immediately subtract to find the third one. So now to find an angle, we're going to have to use an inverse trig function. So in this case, we don't have a directive to do something immediately. Let's look at this triangle. That I totally didn't draw to scale because I always put alpha up here. So we don't know what alpha is. We don't know what beta is. We do know that side B is equal to 12, and we know that side A is equal to 5. We have a right angle here because gamma is our right angle. There's our 3 given information, and C is going to be our hypotenuse. So we have two of the sides of a right triangle. What's something where we don't have to involve trig functions yet? Not necessarily the easiest. We can either start using trig functions. See, this is the difficult part. We have choices. Once we have choices, then the math problem becomes that much more difficult. But one thing we can do is note that we have two of the sides of a right triangle. We can use the Pythagorean theorem to find the third side. So we don't have two angles. Yet. So we're not going to subtract to find the third side, but we do subtract to find the third angle. So one of our options is to go after the hypotenuse. We have two sides, so we can get the hypotenuse. Which in this case is the hypotenuse. So 5 squared, a squared plus b squared is equal to c squared. So c squared is 25 and 144, excuse me, which is 169. So that tells us that c is equal to 13. Excuse me. Now we have an abundance of information, and we didn't have to do this one. Well, we didn't have to do the angle thing first, but now we have an abundance of information, and so now we have a choice. In this case, we can use any of the three sides. We have, for alpha and beta, we have an opposite, adjacent, and now the hypotenuse. So to find an angle, we're going to need to use an inverse trig function. That's something that we should be thinking of, we should recognize right now. We don't know the angles alpha and beta, and we have to remember to find an angle, we use inverse trig functions. To find an angle, we use inverse trig functions. This is something that we should be thinking right away. To find an angle, we use inverse trig functions. So let's suppose that we wanted to find alpha. So what is A relative to alpha? A is opposite alpha. And the B is 12 is what relative to alpha? Adjacent. So what trig function involves opposite and adjacent? Oops, spelled J wrong. Tangent. Awesome. So since we have the opposite and the adjacent, we're going to use tangent. Now, this is just one line of thinking. We could use sine because we have opposite, and we also have C as the hypotenuse. I could use cosine because B is adjacent and C is the hypotenuse. We have choices, and that makes things difficult. So here's an extra strategy. If given the choice, use more given information. It's nice that this came out to be a nice 13, but if it was a weirdo number like the square root of 14 or the square root of 170, then that number's been rounded off. So as a strategy, use as much given information as possible. So I'm going to use this. I chose opposite and adjacent because that was the information I was given relative to alpha. Sometimes we don't have this choice, but another strategy that we want to employ is to use the given information whenever it's possible. Lean into your given information. That's why I picked the 5 and 12, because those are the ones that were given to me. I know that those values are exactly correct. I know that the 13 is exactly correct because if building a right triangle, I tend to lean towards Pythagorean triples. But in general, we want to use the given information whenever possible. We were given 5 and 12, and in relation to alpha that we're looking for, that's opposite and adjacent. So I'm going to use tangent. And then we'll just set up the ratio. Tangent of alpha is opposite over adjacent. Here's where the inverse trig function comes in. Alpha will be the inverse tangent of 5 over 12. I'm going to write it this way because that's how I'm going to type it in my calculating machine. Oops, we don't need that. I'm going to do second tangent for tangent inverse. 5 divided by 12, close parentheses, equals 22.6 degrees. Any questions? At this point, as soon as we have two angles, we should subtract to find the third. So as soon as I know that this 22.6 is another angle. As soon as I have two angles, I'll subtract to find the third. And then the third angle is going to be 67.4. So now, once we have two angles, 90 and the 22.6, I'll subtract to find the third. So angle beta is 180 minus 90 minus our newly found alpha of 22.6. Oops. 22.6. And that gives us 67.4. As soon as we have two angles, subtract to find the third. As soon as we have two angles, subtract to find the third. Any questions? We went a little bit over time today. Sorry about that. All right, that's it for today. That's it for this week. Expect another quiz to show up that you'll have to use inverse trig functions on. Make sure you contribute to the discussion for where we're going to discuss these strategies. And make sure you think about these strategies when you go about solving the problems on the homework and solving the problems on the quiz. That's going to do it for today. That's going to do it for this week. I'll see y'all on Monday, and thanks for playing.